I know he told me to go do the bus at 2:30 or something.
You might head on. I will record for you. Now, Addison. Okay. All right. Okay. We are going to use our calculators to get those out. Did you? Yeah. Yes, it's going to be on AP Classroom. Have you used that for any other classes before? It's fine. Huh? Okay, yeah. Once you get logged into AP Classroom, it should be the only assignment, or it should be easy to find. So, okay. Okay. All right. Has that been in your book bag since last year, Thomas? Do not open the powdered, don't open them in here, please. Please. Alright. When Daniel's out tomorrow, we know why. He might need to use all 3 bathroom passes. Okay. Alright. Okay. So. Alright, everybody. Sometimes Thomas Hunter wants to be just like you. He asks me things about you sometimes because you're a good soccer player and he wants to be like you. And I'm not going to tell him that you have granola bars from 3 years ago in your book bag because it's true. Because he is definitely exactly like that right now, and I'm trying to get him not to be. So I'm not going to tell him Thomas has stuff like that in his book bag because he'll think that, yeah, blood sugar starts to drop. You gotta, yeah. You can use mine. Well, where is mine? Yeah. Okay. So I'm not going to let him know that you do that because then he will think that it's okay because Thomas does it. Yeah. Yeah. All right. Okay, quiet. Okay, so we're going to learn just a couple things about how to use the calculator first before we get into numerical limits, okay? So numerical limits, we will be looking at tables of numbers, right? Tables of values to decide what the limits will be. So first we just need to know how to do the table on these calculators because they're a little bit different. So to get to the table on your calculator, you're going to press the green button and F5. You can see it should say in green table above that. So green table. All right. So you can see the table. My calculator already has something in it, so something's showing up. Yours might be empty depending on what you have there. Like I said, you don't have to reset these calculators, so it might have something in it where somebody has used it before. It might be from their AP exam, actually. All right. For what we're going to do, it is going to be helpful. Guys, quiet and paying attention. It's going to be helpful to change this to the x variable to ask. To do that, we're going to press, you can see up here, see these little tabs that show up at the top of your screen? We want to go to setup, so we're going to click F2. Click F2 and see if it looks like this screen here. Okay. You'll have probably different numbers here, but you should have the same screen. Table start, changing table. So, here is where you can set up your table. So like if you wanted it to start at 1 and count by 1, you could change this to 1 and 1 here. But what we want to do is we want to go down to the line that says independent. That's talking about your independent variable, which is your x. And we're going to click over and we're going to change it to ask. And make sure you click enter and then enter again to save. If you don't click enter and enter again to save, it's not going to do it. So just to show you again, F2, you go down to this line that says independent, click the over arrow, change it to ask, and then hit enter so that it'll save it. So now I'm not even sure what function I have in my Y1 here, but if I type in 2, it'll give me the value at 2. If I want to type in 30, it'll give me whatever the value of the function is at 30. So I can just type in whatever numbers I want. Okay, has everybody got that set up? Okay, so this will help us when we're looking at numerical limits. So let's look here. So use the table on your calculator to estimate the limit as x approaches 2 from the right of 2 natural log of x minus 2. So our function that we're working with here is 2 natural log of x minus 2. So we're going to go to y equals. To get to y equals on this calculator, you've got to hit the green button and F1. So I had this crazy function here. You guys probably have something else crazy. We're just going to go up there, hit clear to clear it out, and type in your 2 natural log x minus 2. Natural log is the, yours is not yellow, is it? The new ones, what are they? It's a blue button, isn't it? Blue button and the X. And then hit enter, yes. So you should have this in your Y1. Everybody okay there? Okay. All right, so let's go back to our table. So we're going to hit green button F5. That takes us to table. Okay. Mine is actually saying negative infinity. Somebody else's? If you type in 2, does it say negative infinity for anybody else? Huh. I don't know why mine does that. But if I type in 2. Okay, so if you type in 2, everybody else is getting undefined. Mine, for some reason, is giving me negative infinity, which may end up being the answer here. But it usually says undefined, so I'm not really sure about that. So since you're getting undefined, that's telling you got something going on at that point. Maybe an asymptote, it might be a hole in the graph. You got something going on where it's not defined at that point. So if we want to see numerically what's happening as we approach 2 from the right, then we would start with some number bigger than 2. Right? Let's go with 3. Radians, always and forever. Only radians are on the AP exam, so everything will be in radians. It should be default, so it should be in radians anyway. Although it doesn't matter for this because that's not trig, so it would only matter for trig. But. So I just typed in 3 and I got 0. Have you guys got? I just, right here, just type 3 and hit enter, and you should get 0. All right. Give me a number closer to 2. Closer to 2. 2.5 is closer. This time I got negative 1.386. Give me something even closer. 2.2. All right. Even closer. 2.1. Then I heard somebody say 2.01. What about if I do 2.001? We're trying to get closer. Because, see, this right here means we're approaching 2 from the right. Right would be positive values, right? So we're getting closer and closer and closer to 2 from the right. So this number is even closer to 2. The more zeros I put, the closer I get. And it looks like it's just getting lower and lower and lower. Do you not have a negative? Well, like I've got negative 23.03. Okay, it's getting bigger but smaller. Yeah. So if I try 2.0006, I'm going to just put lots of zeros. I got negative 41. What if I put even more zeros? Mine says negative infinity. That's probably when you're getting undefined. And it doesn't necessarily mean it's undefined. It means the calculator can't handle it anymore, so it's telling you undefined. So these numbers just keep getting smaller and smaller and smaller, right? More and more and more negative. So because it doesn't seem to be evening out at one value, it appears that this should be negative infinity.
So the thing is when I look at my table, it just says undefined. And when I go to the graph, it doesn't even have the same issue. It doesn't approach to it.
If you type in like 2.5, is it giving you undefined?
That's the only number ever. That's the only number ever.
All right, now type in 2.1.
I think the default numbers that are in the table are too far left of the line. There's not a line there.
You should be on ask. So we're typing in numbers that are just getting closer and closer and closer and closer. I actually typed in 2.00001. It's just rounding it to 2. All right, so everybody quiet and listen. Okay? So what we're doing here is, first of all, numerical limits do not prove for 100% sure that anything has that limit. It's an estimate is what we're looking at. So what we were seeing is these numbers kept getting lower and lower and lower and lower, which would make us think that it's probably going to negative infinity. All right, so that is our guess. Now, no, mine did say negative infinity, which I've not seen on these calculators before. I think this is like, I'm not sure why it does that, but that was our guess. That's what's happening. Now, if the limit was actually negative 10,000, and that limit actually existed, we would miss it here because it looks like it's going to negative infinity, but it's really negative 10,000 instead. So this is a good estimate. It is not necessarily going to always give us the correct answer, but it's our estimate. So let's try another one, okay? So this time, we're doing this function. So we're going to go back to y equals. I'm going to clear out what I had before. What's it say?
It's just not responding. Then I went on the graph and I got out of pocket and I drew a line. I don't know. Well, there's an infinity button.
Sometimes if you can enter while it's graphing, it pauses it. And so it won't let you do anything until you hit enter again and then pause it.
Okay, so I have a question. Where's the stereo?
Alright. Okay. Alright, so one thing I love about the TI-89s is it puts it in like actual math notation. So it should look like this, which matches the actual math notation, not just stuff with parentheses. So has everybody got theirs in white? 1.
That's pretty cool.
Yeah, there's no square button on these, so you just have to do 2 to the second power. All right, are we okay? Okay to go? All right, let's go to the table. No, you can clear it out. Okay, this time, what is our number, our x approaching? Infinity. So we could start maybe at 0, right here, right here. So I put 0, I got negative 0.125, but then I need numbers to get larger and larger and larger, right? So maybe 10. And then maybe 100. Then 1,000. And 10,000. Oh, what does it look like is happening here? Alright, that E with the negative means you're moving that decimal 6 places to the left, so we're getting really close to 0 here, right? So it appears here, as those numbers get larger and larger and larger and larger, right, as our x's approach infinity, it appears that our y coordinate approaches 0. So our guess for this would be 0. Our educated guess. Okay, so you can see here, like at first it looked like the numbers were going to get bigger, right? But then it turned around and started getting smaller and smaller. So that's why you want to do more than just one number. You want to start using those numbers larger and larger to see what's happening. Okay? All right, questions? All right, example 3. Which of the following statements is supported by the table below? So it doesn't mean it's necessarily true, but it is supported by the table. Okay, so A says the limit as x approaches 2, which 2 would fall right here. We don't actually have 2, right? 2 would fall right here between 1.999 and 2.001. Alright. Does that limit as x approaches 2 of f of x equal negative 4? It does from the left side, but does it from the right side? No, because you're getting a positive over here, so it's not A. Alright. What about B? It's the same thing, but from the right. As we get closer to 2 from the right, we have 3, 3.5, 3.83, 3.92. It looks like it's getting closer to maybe 4, right? So, not negative 4. You'll have like a jump in the graph there probably. Does the limit as x approaches negative 4 of f of x equal 2? We don't even really know what's happening with negative 4, do we? Right? So, alright. I am remembering now that I clearly forgot to fix this. D is also not right, but it's not right because my notation is so bad. What's wrong? So, whenever we take a limit of something, when we take a limit, it has to be a limit of something. And mine is just limit empty, right? I don't have anything there, so I really should have right there. Squeeze this in. Of f of x equals negative 4. Hold on. Regular 4? Okay, there we go. Regular 4. So, that f of x does need to be there. That was poor notation on my part. I apologize for that. But if it was f of x was there, D is the correct answer because you get closer and closer to 4. Now, it doesn't guarantee it's the case, but this table supports that idea. Okay, questions? All right. Which of the following statements should... I need to go back through these. I have 3 preps, 3 different classes I got to get everything ready for. There's not a lot of proofreading that goes on. Just getting it done. Yeah, okay. Which of the following statements must be false according to the table below? And we, no, most of them are asking about 0, but we do have one that asks us about negative 5.5. All right, so like for example, when we're checking to see right here for A, x approaches 0, which tells me that I'm looking wherever x is 0. So that's right here, right? And so I'm looking to see that the y value I'm looking to see that the y value does not exist. So it would be a case where, like, from one side it equals one thing and from the other it does not equal something. I can probably explain this better from this one. Like for B, limit as x approaches 0, we're still looking at the spot where x is 0. And the limit of this function is negative 5.5. So your y value is negative 5.5. Okay, B looks like what's happening here, right? So that is not the correct answer because it looks like it's probably true. All right. So does it look like the limit from the right and the limit from the left are the same at 0? It looks like they're going to go to the same value, right? So that looks like it should be true, so it's not the answer. Yeah. This one asks which one is false. So, because this is true and this one is true, and we're looking for false. All right. Limit as x approaches 0 of f of x does not exist. It could potentially not exist.
Okay, I guess, is it like just like it can just like go steady?
Yeah.
Like a U.
Yeah, it could. There could be some sort of crazy asymptote that happens here. It's unlikely, but it could happen. I think that I've messed this one up too. There's a possibility. I think I meant that to be negative 0.5 instead of negative 5.5, but I could be wrong. So we don't have information for negative 5.5, right? Is it a possibility that it does equal 0? It could. We don't know what it is, right? I think I meant for this to be negative 0.5. Yeah, it's possible. And really, even if it didn't, it's still possible. As they were written. Yeah. Even though I really gotta go back and proofread these notes. Why didn't I fix anything? Even if I change that, it's still not guaranteed to be false. Let's just leave it like it was. No answer. Sorry about this, guys.